Okay, yet again, another rambling on and on and on where I lose my sense of time. I hope that I've addressed the so-called indexing argument by Professor Zankin and others, where something that I consider, for one thing, to be an argument based more on sophistry than on anything. I hope I've addressed it. If I've misunderstood its deeper dimensions, then I'm just going to have to let it stand at this point. I don't consider it a valid argument to begin with. Okay, because if you could prove countability, if let's say this diagonal here is A, if A then B, in other words, if this diagonal argument here then uncountable, doesn't necessarily mean that if not some other diagonal, then it's countable. I mean, it doesn't have to be uncountable any way you cut it. It just has to be uncountable. The argument just has to be established one way that you cut it, and it's established. Okay. But on the deeper issue that I think my opponent disagrees with me on, deserves, I'll respect him on this. I respect people who go to the older Aristotelian tradition. That's very logical. It's very common sense. However, it's flawed philosophically, and I'm going to put it like this. In mathematics, really is a form of, it's not an empirical science. It's a mix between empirical science and liberal art. My own background is more liberal arts than empirical science. I admit that. I'm open about it. Mathematics is a liberal art, and I feel I can comment on it based on the knowledge I have. And based on a knowledge of philosophy, I would say this. If you're going to talk about philosophy, you're going to talk about categories. And if a category can be constructed, then from the standpoint of philosophy, it exists. I didn't say necessarily the standpoint of mathematics, but from the standpoint of philosophy. If you're going to construct category A, then not A exists from the standpoint of pure logic and philosophy. Now, empirical science doesn't work that way. If you discover A and you don't discover not A, then not A doesn't exist. I mean, purple people eating monsters don't exist. Maybe they do on the internet somewhere, but most scientists would say, no, they don't exist. However, from the standpoint of formal logic, if you can construct the idea of a purple people eating monster, you can consider it, then it exists. Well, if we can construct the idea of the finite, or let's say the number 1, start with counting numbers, the number 2, the number 3, the number 4, the number 5, and we construct the idea of a recursion that has an end. 1, 2, 3, 4, 5, back to nursery school, right? Counting. How you count it is in nursery school is the perfect way to understand some very advanced forms of number theory, right? That just deal with counting numbers. Okay, well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and it stops. So you have, you don't have to worry about the halting problem in nursery school. The teacher tells you when to stop and you stop, right? And then you learn how to count by twos. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. And then, you start taking number theory and you realize that you can have a one-to-one correspondence. And, you learn all kinds of neat things. Eventually you learn about prime numbers and modularity and all that stuff. But the important point here is you now have a concept that you've constructed. You can call it category A, and that's the category of the finite. Well, whenever you consider formal logic, anything, this is going to almost sound a little bit Eastern. I think Western philosophy has a difficult time understanding this. But to understand being, you have to understand not being. To understand a set, you have to understand the null set. To understand A, you have to acknowledge not A. It doesn't matter whether not A has an, quote, actual existence or not. If it's constructible, it exists as a concept. Because otherwise, finite has no meaning. Otherwise, I think my opponent doesn't believe in mathematical Platonism, period. I have no argument with him. The problem is, if I can establish one inconsistency, then I would hypothetically demolish his argument. Well, the inconsistency is, if he's in the store and he counts 2 apples and 2 apples, he has 4 apples. But I know the argument's a little more complicated than that. They would claim it's more of a tautology. All right, fine. But if you accept those Platonists who do accept the idea of the finite, they're, I guess, the finitists. I've just sort of come across them recently, so I'll try to do justice to their arguments as best I can. If you accept the idea that there is a finite realm mathematically, like the number 5, that there is an existence to the number 5, at least as an abstraction or a generality, then you have acknowledged 6, you have acknowledged 7, 8, 9, 10, 11, 12, 13, 14. But more generally, if you acknowledge the idea of a recursion that halts and call that category A, you have acknowledged not A. Now, you might say that not A has no physical existence. You know, even the universe itself, probably most cosmologists believe is finite but unbounded. I know there are a few who talk about an infinite universe and all the rest of it. So many cosmological theories these days, it's hard to keep track of them. But the bottom line is, unless you can show me a reason that the numerical realm stops at some universal set U that is finite, and that but then the problem is right there. I can say, well, what about U plus 1? Only the infinite gets us beyond, to where U plus 1 is just U. There's, U plus 1 goes to U. I mean, only the infinite set really does that for us, and that, I believe, would be Aleph Naught, and not these higher level, quote, cardinalities, end quote. But that's another subject. Okay, I believe, I accept the existence of these higher level cardinalities. I just don't call them cardinalities. I would use another term. So the bottom line is, I don't believe that there is a potential actual distinction when it comes to mathematics. I mean, even the number 5, can you actually get to the number 5 as in 5 equal quantities? I mean, of anything? Even a Planck's radius of difference? No, that's not possible. That's a potentiality. And yet, 5 is treated, for purposes of mathematics, like an actuality. Or the number 1. I mean, there actually is a series that will get us the number 1. 0.999999999. If you do not halt, will converge on the number 1. That is provable. And you can actually prove that algebraic. You don't even need calculus. You can prove it algebraically. All right. Well, the nature of infinity to me is maybe something that can't be understood fully via mathematics or fully via Western-style philosophy, because too many of our categories and ways of analyzing things rest on finite assumptions. However, I believe that from the standpoint of mathematics, you're not talking about physical reality. I mean, you are not, by definition of what mathematics is, it's an abstraction. And therefore, when you get into the realm of formal logic, unless not A is contradictory, but see, then the problem is you've defined A. If there's no such thing as not A, then A becomes the universal set. And, A, in my opinion, ceases to have meaning. So unless not A is completely contradictory, where there is no way to get out of the contradiction, you're going to be stuck with not A. So not finite becomes, and I have not found any real contradiction in not finite as a concept. There may be paradoxes, but I have not found a fundamental contradiction in the idea of not finite. Therefore, A and not A are both categories that need to be respected. Again, there are paradoxes, but I don't believe there are really contradictions. Okay, I thank you for watching these 2 videos. I'm sorry the first one took a little long.